what I'm going to do is, I'm not going to repeat myself. If I do this in this class, I'm not going to do the same problem in the next class, and vice versa. So, just because I don't do something in here doesn't mean you're not responsible for it. I.e., I did a video on expectations, and I talked about, I think, even though I may not have, but whatever, doing the problems in the back of the chapter. And remember, they're all through the chapter, so you have to actually find them. So that may take some time. All odd problems, yes. Now, one of the ideas, and also the online text is a little different from the regular text, and you do the homework from the regular text, not the online text. But many or most of the problems that are on the online text is the same. Okay, clear? Yes? Okay. So if I say to you, make these conversions, for instance, we'll do two of them. This is number 59. 98 point, no, this says round off. Okay, we'll do rounding measurements. So this says round off each of these measurements to 3 significant figures. So 98.473 liters. And what I did was, I did round it to 3 significant figures, and I also changed it to scientific notation directly. So this would be, this is the fourth one's rounding the third one, and that's going to round it up, correct? Can you see green doesn't come out too well? Is that correct? So this is going to be 98.5 liters, which is 9.85 times 10 to the 1 liters. That doesn't come out at all, does it? Okay, clear? Clear?
Yes.
So this, if you're going to round it to 3, this one is going to do the rounding. Yes? Okay. So the fourth one is rounding the third one, and basic rules for rounding apply. Okay. The next one says, I feel like I'm reading a teleprompter here as I look down. Right? The next one says 3 zeros and then 76321. 76321. Okay, the next one says 0.000766321. Okay? And then that says to round to 3 significant figures. So the first thing, I suppose, the first one was easy because it only had significant figures. So you have to identify the significant figures, correct? Yes? These are not significant. There will be no rule that identifies them as significant. So the only significant figures are the non-zero ones, correct? Rounded to 3 significant figures. So you're rounding it to 3 significant figures, and that is doing the rounding. Is that going to have any effect on the 3?
No.
No, it's not. So it's going to be 0.000763 or 7.63 times 10 to the negative 1234 negative. Correct? And the book says that that is centigrams. Can we quit there? I think that's pretty straightforward. Do you agree?
Yep.
Yes? All we're doing in this problem is rounding, and then we are converting to scientific notation. Both are going to be important for the test. Now, let's look at another one. Let's see. That should be pretty easy. I can't do all of these. All right, this is a good one. This is actually the one I thought I was doing originally. So 157, so 157 centiseconds seconds. Okay? Small c is centi. I don't give you any conversion factors on the test. I give you no prefixes. You have to either memorize them or write them down in your notes for your tests. I don't give any sheets or anything else. Clear? Okay. So Many of you know what centi is. How do you say 100 years? What's 100 years? Century. 1 year is 100th of a century, for instance. Okay. Right now. So there's going to be 100 centiseconds in a second. Now, the way the book would have you do it would be dimensional analysis. And they would say 157 centiseconds times centiseconds over seconds. In 1 second, there's 10 squared, and then divide and multiply, correct?
Yeah.
Yes, and you're crossing out, and then you're getting, let's see, you're saying 1.57 times 10 to the 2 times 10 to the negative 2. So I took this and I put this in scientific notation. And then I took this, brought it to the top, and that's 10 to the negative 2. And then, so this is going to be 1.57 times 10 to the 0, which is the same as 1.57 centiseconds. Yes? You okay with that? Yes? Yes, what do you need?
Centi means 100.
Hundredth.
Oh, 100.
Hundredth. Yes, hundredth. Okay? So, now, like cents, how many cents are there in a dollar, for instance, if you know?
100.
There's 100, right?
That's why centimeters are meters.
Correct. There's 100 centimeters in a meter. Yeah. You know more than you realize, you know. You just have to put stuff together. All right. But the way I would do it is this is the way I'm trying to get you to do it, because it's the way it was really meant to be done. The metric system was invented because it works on base 10. Base 10 is pretty straightforward. What's 10 times 10? Anybody? 100. What's 10 times 10 times 10? What's 10 times 10 times 10 times 10? 10,000. What's 10 times 200? 2,000. You see how easy it is? You guys can do that very quickly, right? So let's do this a little bit more quickly. Yes? Okay? So 157 centiseconds to seconds, right? Now, how many, what's the, how many of the small guy is in the large guy? In other words, how many centis in a second? What's the exponent? 100, right? How do you write that in exponents? 10 to the second, right? Isn't it? Yes or no? Yes or no?
Yes.
Okay, now, where's the decimal point here for 157? Where's the decimal point? Right here, isn't it? Isn't it?
No, it's after the 1.
You've got some homework to do. As the number 157 is written, the decimal point is after the 7. Okay? And if you don't think so, then you've got some homework to do, some independent study. Okay? All right, now. So that's where the decimal point is. Now, this is what I'm going to ask you. Is this number, Miss Swain, going to become larger or smaller? In other words, when I convert 157 centiseconds into seconds, is the number 157 going to become 157 with 2 more zeros, or 157 as in 1.57? In other words, which way am I going to move the decimal point? Is the number going to be smaller or larger?
Smaller.
It's going to be what? Yeah, are you sure? You knew that right away. That's pretty cool. I'm very impressed. I am. I'm not being sarcastic. I'm known to be that way, right, Red? But I'm really not. I'm being very serious. I am impressed. I didn't expect that, because that was told to me very effectively.
Wow.
Yes, I felt the same way. Now, so it's going to be a smaller number. Well, how much smaller? How many decimal places is it going to be? Well, it's going to be 3 decimal places. I'll give you a hint.
We're going to take enough cents.
Each 10 is a decimal place. Okay.
1.57.
Exactly. So the answer will be 1.57 seconds. See the conversion? You see how easy that is? You don't have to go through that horrid dimensional analysis, which is an utter and absolute, positive, without a doubt, waste of your time. The ground begins to shake. The entire room rumbles. The floor cracks in half. Gas is released from that crack. You hear a violent roar. Up through the crack comes a monster whose mouth is opened wide, grabs onto your leg, and pulls you down into the earth. That's called the time hog. And what happens is you spend all of your time wasted by doing nonsensical, time-wasting things. Do you agree? You know, have you ever gone rabbit hunting? How do you catch a rabbit? This is like an American thing. How do you catch a rabbit? What do you take rabbit hunting with you? How do you catch a rabbit? Well, this is how you catch a rabbit. Are you ready? You go find a rabbit and you put salt on its tail. Please don't interrupt me. Thank you very much, Mohammed. You put salt on its tail and then you grab the rabbit. What's the moral of the story? Leave the shaker at home and just grab the rabbit. So what's the whole point? Please shut the door. Thank you very much, Mohammed. Please shut the door. I'm filming. Thank you very much. You leave the salt shaker at home and you grab the rabbit. By the time you're finished applying this intense mathematical algorithm called dimensional analysis, you could have done 3 or 4 problems. The whole point of the metric system is that it's base 10. So conversions are simple. If you're doing dimensional analysis for the 80th time since you've been in the elementary grades or middle school, it's a waste of time. Learn to use the base 10. Clear? So let's do another one quickly. See if you can do this. Now, instead of going from small to large, we'll go from large to small. So I am on number 70 for those of you who are following along. And it says 42.7 liters to milliliters. Okay? Oftentimes the actual correct is small m, capital L, but I and many people just say small m, small l. It's actually like this, but nobody does that. We just say ml. Okay, now, how many milliliters are there in a liter? What base 10 are you going to use? What are you going to use? What's the exponent? 10 to the what? 10 to the what? How many milliliters? You have to look up the prefix milli, right? 1,000, good, we're getting there. What base 10 would you call that? 10 to the second, is that 1,000? It is. 10 to the second is 1,000. I'm looking at you, shall I take my glasses off? I'm saying 10 to the 2 and you're going, yeah, that sounds right. What base 10, 10 to the what equals 1,000? 10 to the 2? 10 to the 3, you're holding up 4 fingers. 10 to the 3, that's 3 fingers. That's 4 fingers, okay? You all right with that? Miss Great Speech, running for student council. Don't you have to be able to count? That's 4, and that's 3. Okay, excellent. I like that. Now, so 10 to the 3, right? So is that going to become a larger number or a smaller number as I go from large to small? It's going to become smaller. So how many, let's test that. How many milliliters are there in a liter? 1,000, right? How many are in 2? 2,000. How many are in 10? 10,000. Is that number becoming larger or smaller? Larger. They're actually equal, but it's becoming a very large number. So isn't that going to become like 42,000-ish, right? Isn't it? Right? So if I'm going to write that in milliliters, I'm going to say 42,700. Isn't that correct? Yes? Now, what you want to do is you want to put it in scientific notation. So you're going to say 4.27 times 10 to the 4. So look at this. Now it's starting to make sense. Look at this. Well, it's 10 to the third. Well, where did 10 to the 4 come from? Isn't 42 10 to the 1?
No.
Yes, it is. Yes, it is. So that's where 10 to the 1 comes from. So 10 to the 1 here and 10 to the third is 10 to the 4. You see how easy conversions are? I expect you to be able to do metric system conversions as they were meant to be done. And that is by manipulating base 10 values with decimal places. And hey, we're finished. Let's go to lunch.